So we are for, of course, we are following the green chemistry protocols in this process, as you said. To follow the green chemistry protocol, we should know the catalyst, replacement of catalyst with the green reagents. The how existing catalyst, that knowledge of existing catalyst, classical existing catalyst can be replaced with the green catalyst, but there is no disturbance in the reaction scheme. Without disturbing the reaction scheme, if we are following the replacement of catalyst and getting same kind of product, that is nothing but the green chemistry protocol. It means that we are eliminating the all hazardous chemical, and we are introducing the eco-friendly catalyst, which will give the same product with the best yield. Yield अच्छी आएगी, we are going to get the same product. Suppose what 2 3 reaction we have done, we got the same product, but only we have replaced the catalyst. Like that we have done acetanolide synthesis. In condensation we have done with the benzimidazole. In halogenation we have done no parabromoacetanolide. In lab I have not done it, but I will do later, day or day after tomorrow. Halogenation, then nitration is there, nitration will carry out later, but we'll continue with the hydrolysis process. So we are having total 9 experiments. Total 9 experiment. I'm going to write over here how many experiment. Acetylation is there, okay, in your syllabus according to your university syllabus. The practical, what we have to done, what we have to learn, the reaction scheme with the DST protocol is acetylation. Okay, under acetylation we have to follow any one kind of synthesis of one kind of product, that is aspirin or acetanolide. Aspirin with the microwave method and acetanolide with the DST protocol method, as well as the classical method. So we have done with the acetylation. Acetylation के अंदर we have used the acetic anhydride. ठीक है, we have used acetic anhydride in classical method, and the acetic acid in green chemistry protocol. ठीक है, from acetylation method we have synthesized the acetanolide. ठीक है, why I am repeating means viva question you are going to get. Acetanolide. Then first reaction what we have learned with the acetylating reagent. Next we have done the condensation process. Condensation without using any kind of catalyst. So this one, condensation reactions are those reactions two molecule can be clubbed together to make one drug molecule. So that method is called as condensation method. Here in this methodology, condensation reaction, we have done the synthesis of benzimidazole. हम यहाँ पे क्या किए, synthesis of benzimidazole. ये किया हम लोगों ने, we have done the benzimidazole synthesis. So condensation के अंदर, and third reaction, named reaction. Now what we are going to, halogenation. Halogenation किया क्या हम लोगों ने, ब्रोमोएसिटेनोलाइड नहीं ना,
हुआ मैम,
हुआ ना. Then we have done the halogenation. The halogenation is the para-bromoacetanolide, that is synthesis of para-bromoacetanolide. So this we have done, acetanolide. So this we have done. Then fourth, today in this uh, session, what we are going to do, we are going to learn the halogenation reaction. We are going to learn the halogenation. Halogenation done, no? Hydrolysis, sorry, halogenation तो किया ना, ऊपर ही मैंने बता दिया, sorry. Halogenation we have done, and today we learn the reaction hydrolysis. With hydrolysis, how we are going to synthesize the molecule. By following this reaction, what kind of molecule we are going to synthesize. Here we are going to synthesize, example already given, already mentioned in your syllabus, example related to hydrolysis. That is hydrolysis of methyl benzoate. हमको क्या करना है, मिथाइल बेंजोएट का हाइड्रोलाइसिस करना है, बेंजोएट. सो वीडियो रिलेटेड टू दिस आई हैव डन. तो ये 2 के बनाना है, 3 के. डे आफ्टर टुमारो इफ आई एम गेटिंग टाइम देन आई विल मेक द वीडियो एंड फॉरवर्ड यू ऑल द लिंक्स टू ऑन आवर ग्रुप. ठीक है. नाउ वी आर गोइंग टू कैरी आउट द फोर्थ रिएक्शन प्रोसेस, दैट इज हाइड्रोलाइसिस. So for my section, no need to write any kind of journal, but you learn the reaction, practice the reaction. ठीक है. So these only the questions what you are getting in your examination, but soft copy are related to this. I am going to forward you all the DST protocol, then rules, principle behind the DST protocol, then the reaction as well as process, principle, everything I am going to forward you people at the end of the experiment. Not now, right now I am not going to send you. So today we are going to discuss this reaction condition. Next experiment, likewise we are having 9 reaction. So after completion of ninth reaction, I am going to forward you the soft copy related to this. Okay. Today we are going to learn with the hydrolysis process how we are going to synthesize the methyl benzoate. Methyl benzoate कैसे बनाना है वो सीखेंगे. From the methyl benzoate what we are going to get, that also we are going to learn here. Okay. So now the general reaction, we are going to see the general reaction condition of methyl benzoate. So synthesis of our aim is synthesize the methyl benzoate, synthesize the methyl benzoate, methyl benzoate, benzoate by hydrolysis, by हाइड्रोलाइसिस प्रोसेस. ठीक है. हाइड्रोलाइसिस ये क्या है अपना, हाइड्रोलाइसिस, हाइड्रोलाइसिस है ये रिएक्शन. ठीक है. एम, फॉर द रेफरेंस वी हैव फॉलोड द वोगल टेक्स्ट बुक ऑफ प्रैक्टिकल ऑर्गेनिक केमिस्ट्री. दैट रेफरेंस आई एम गोइंग टू मेंशन इन द सॉफ्ट कॉपी. द रेफरेंस वी हैव फॉलोड द वोगल टू कैरी आउट दिस प्रोटोकॉल. नाउ द जनरल रिएक्शन apparatus क्या चाहिए हम लोगों को इसके लिए, apparatus what we required in our lab means we required the RB flask, and next we required the burner, condenser, glass rod, pipette, सारा सब कुछ जो भी चाहिए इसको बनाने के लिए, that all the apparatus we need all those apparatus I'm going to mention in the soft copy, but we required general reaction. What is there in the synthesis of methyl benzoate is we are having this reaction. Wait. With methyl benzoate we are going to get the benzoic acid. methyl benzoate से हमको मिलेगा benzoic acid. So that reaction we are going to follow in this condition. So here we are going to take this molecule ethyl benzoate, ester kind of carbonyl group, methyl benzoate, ester C double bond OOOCOO, but it is methyl benzoate. Okay. So this methyl benzoate, we are converting this methyl benzoate into salt form by using sodium hydroxide and amount of hydrochloric acid. Okay. So we are going to get, with this hydrolysis process we are going to get the benzoic acid. So what we have to do in this reaction condition, we have to use the methyl benzoate, and we have to add the sodium hydroxide to that. Then we are going with, in presence of hydrochloric acid, we are going to get the benzoic acid. Okay. Benzoic acid. listen, here we are converting this one into salt form. Okay, that salt will release the OCH3 group which is there, then addition of hydroxyl group to that condition we are going to get the benzoic acid. For this we required so much of time. Here we are not using any kind of carcinogenic hazardous chemicals, that's why there is no protocol over here in this reaction. Okay, so this is the reaction what we are having. So these are the two, this is one is the starting material what we have utilized, this one is the end product. ठीक है, from which what we are going to get. So calculation के लिए हमको ये दो चीजें चाहिए. Now we'll see the mechanism behind this one, the mechanism behind, इसके पीछे मैकेनिज्म क्या है भाई, कैसे बन रहा है प्रोडक्ट. जनरल मैकेनिज्म स्टेप बाय स्टेप आई एम गोइंग टू एक्सप्लेन यू. In the first step what will happen, the hydroxyl, always whenever the mechanism of reaction will going to takes place, it is going to be takes place in a three step. ठीक है, mm, you remember whatever it may be the named reaction. ठीक है, that named reaction will follow first three steps. Differentiation of steps from third step onward in each and every mechanistic approach of the reaction. Difference कब आएगा, जब third step start हो जाएगा, the named reaction differentiation will come. Whatever it may be the mechanism, the first step in the mechanism is breaking of bond between the catalyst. Catalyst के bond पहले break होंगे जब भी हम flask reaction कर रहे हैं lab में. So when we are introducing the reactant as well as catalyst to the beaker, first step of the reaction is not with the starting material what we have utilized, the reaction between the catalyst, because these are inorganic molecule. To hit this one, it has to convert into electrophile or nucleophile. When it will get convert into electrophile and nucleophile, that moment in the same temperature and pressure, this is also getting and this is also undergo different kind of canonical structure. That canonical structure will get attack with the electrophile or nucleophile what is already generated in the flask. So then that moments, so these are least to attract, these are very keen to attract with the nucleophile or electrophile present in the flask reaction. So each and every moment you should know what is happening, but which one is weak, which one is strong. Now this one is a strong. If it is strong, it required the strongest kind of electrophile. If it is nucleophile, it required electrophile. If it is electrophile, requires nucleophile. ठीक है. Now first step of the mechanism is attack by conversion of catalyst into electrophile or nucleophile. Now electrophile will get generated in the sodium hydroxide. From sodium hydroxide we are going to generate the electrophile plus nucleophile both. On the basis of that, this will also convert into nucleophile or electrophile. So now first step is step 1. Step 1 में क्या हो रहा है, attack by OH. ठीक है, OH means the NaOH, NaOH. ठीक ठीक है. So this one is negative, this one is positive. So in presence of hydrochloric acid, it will convert into Na plus and OH minus. ठीक है, in presence of HCl. So HCl, this one is a minus and this one is a plus. तो add नहीं होगा, but in presence of proton it will get converted into sodium chloride and water, but we required one OH from the sodium molecule. So we'll get attack of this molecule with this. So whenever down the arrow mark, if any kind of acids were there, that were not going to get interact with this catalyst. First of all, the bond between the catalyst will get broken. When the bond between the catalyst will get broken, the Sodium will convert it into plus charge, positively charged ion, and this will convert into negatively charged ion. जब ये पॉजिटिव और नेगेटिव में कन्वर्ट हो जाएगा, that time the strongest one is this, because we are having the methoxy group and carbonyl group. So this will get react with the carbon in presence of this oxygen atom. It will get attacked. I will write the reaction, then you will come to know. At the place of this benzene ring, I'm going to write R. I'm not going to write full reaction. Okay, so here I'm going to write the carbonyl group, of course, and I will write O at the R dash. This is methyl group. General reaction scheme I'm going to write. So in place of R, we are having aromatic compound benzene ring, and in place of R dash we are having CH3 ग्रुप. ठीक है, R3 के पास CH3, ये CH3 है और ये R है, R डैश के पास CH3 है, ये aromatic component है. Now it will easy to write the mechanistic approach. ठीक है, attack by hydroxyl group on electron deficient carbonyl carbon, on electron deficient carbonyl carbon, that is this ketone group, carbonyl carbon. So here, see, this OH will not going to attack to this anywhere it not going to attack anywhere on the aromatic component, because it is already stabilized molecule. The weakest bond which is there is pi bond between pi bond and carbonyl atom. So it is least stable one. It is not fully stable, but this one is stable because it is connected to the मिथाइल ग्रुप. अब हमारा OH कहाँ अटैक करेगा, जो वीकेस्ट पार्ट है वहां पे अटैक करेगा. द वीकेस्ट पार्ट कौन सा है अपने पास, ये पार्ट है. तो ये पार्ट जब अटैक करेगा उसके ऊपर, ये नेगेटिव में कन्वर्ट होगा पॉजिटिव, देन दिस OH विल बिकम नेगेटिव. अब ये नेगेटिव में कन्वर्ट होगा, यहाँ का जो उसका डो पॉजिटिव रहेगा, ऊपर वाले का डो नेगेटिव रहेगा. सो दिस नेगेटिवली चार्ज हाइड्रोक्साइल आयन will get introduced at this position. It will get broken. When it will get broken, it will get interact. ठीक है, जब भी ये कार्बोनियल का बाउंड ब्रेक होगा, इधर देखो आप लोग, ये कार्बोनियल का बाउंड जब भी ब्रेक होगा वो इस तरीके से ब्रेक होगा. whenever it will get attack, this one is डो नेगेटिव and this one is डो पॉजिटिव. ठीक है, और जो डो पॉजिटिव वाला पार्ट है, देयर दिस विल गेट इंट्रोड्यूस. In the same way, what we are going to get, the first step of the reaction we are getting in this format. O is already negative because it got broken with the pi bond. Now this one is a dou positive. Where it is dou positive, the hydroxyl group will already got introduced at the least stable position, that is carbonyl. So this one is the electrophilic nucleophilic addition reaction, because this nucleophile got added into the electrophilic part, a positively charged part of the carbonyl group. So this one is our O and R as it is. So the first step is attack by hydroxyl group or OH on electron deficient carbonyl carbon. अटैक हो गया इलेक्ट्रॉन डिफिशिएंट कार्बोनाइल कार्बन. जब ये ब्रेक हुआ तो ये इलेक्ट्रॉन डिफिशिएंट हो गया, यहाँ पे पॉजिटिव बन गया. सो दैट इज पॉजिटिव. देन द नेगेटिव विल गेट attracted with the positive, then it will make one bond with this material, then we got OH group got introduced into this. That is the first step. In the step 2, what will happen in the step 2 of the reaction process, elimination of OR. So our aim is to synthesize the benzoic acid. By keeping in mind, we have added the catalyst. The step 1, the next step is elimination. Next step is elimination. What we are eliminating? Elimination of OR. OR dash now. So this OR has to get eliminated from that reaction condition. So how it will get eliminated? Elimination. First breaking of the bond, then making of the bond. It has made one bond, broken the bond between the inorganic, made one bond, and elimination of OR from the reaction condition. So how it will get eliminated? Now this one is an R, this one is O. Of course, what we have got, that same thing we are going to write over here. So just what we required, we have to eliminate this OR from the reaction condition. Now this one is a reversible reaction, not direct reaction. Now, what will happen? Elimination of OR from the reaction. When we are going to eliminate OR, because already we are having OH got eliminated, OR is left, this negative charge will react with sodium ion, then it will get eliminated sodium OR anything, sodium methoxide, like that it will get eliminated. But in this reaction, we are going to write general reaction process, because sodium we are not mentioning in the reaction, but it is understood that it got eliminated with the sodium particles. So this OR in place of OR, so we are going to get elimination of ओ आर डैश के पास हमको क्या मिलेगा, दैट एलिमिनेशन ऑफ ओ आर एंड addition of elimination of not O or elimination of or then addition of nucleophile OH. ठीक है, water molecule elimination, hydrolysis reaction, it is hydrolysis. Now to eliminate this OR, we are going to make it hydrolyzed. When we are hydrolyzing, OR will get eliminated, the OH will get add up into the product OR, it got eliminated. So OR got eliminated, so we got OH over here. So likewise, when we are getting OH, the transformation of proton will take place. The transformation of proton further leads to formation of negatively charged ion. Sorry, OR got eliminated. मैंने ही गलत लिखा. So OR got eliminated. Wait. So OR will get eliminated from the reaction. जैसे ये OR निकल जाएगा, ठीक है, the R, ये OR निकल जाएगा, then it will make remaining amount of molecule. So जो positively negatively charged OR निकल गया, then positive charge is left over, that positively charge make the pi bond with this, then we are having one more OH. Likewise, we are going to get benzoic acid, and this one will eliminate as an free radical OR. So this one will eliminate as an फ्री रेडिकल. अब ये पॉजिटिव चार्ज होगा, ये निकल जाने के बाद बचा क्या, पॉजिटिव चार्ज, दैट पॉजिटिव एंड नेगेटिव मेक will gather to make one bond. So again it will get converted into carbonyl group. Then this OH will come into this place. Already it is there. Then it got stabilized. Now we got the benzoic acid over here. So still this thing is there in our flask. To remove this one, what we are going to do, we are going to protonate this one. ठीक है, अब ये तो हमने कर दिया भाई. Okay, in our flask we are having this reaction. So to remove this reaction in combination with this methoxide, R डैश के प्लेस में CH3 है, O is already there. ठीक है, अब ये O or R as an free radical which is already merged with the benzoic acid. So to remove that OR, what we are going to do, we are going to protonate this one. What we are going to do, we are going to make an hydrolysis. अब यहाँ step पे hydrolysis follow होगा. Eliminate हो गया. Now we are going in the third step, step 3. What we are going to do in the step 3, what we'll do the transformation of proton we are going to transfer to OR. So now this one is a free radical, we are going to give proton to this one. The moment when we are going to give proton to this one, it will get eliminated from separated from the product as an byproduct. That will be very easy to uh, isolate our benzoic acid in a liquid form. Now this one is a solid form, this one is in liquid form. Okay, now this is not an product, this is not an product, not an reactant, it is nothing, it is a mixture, it is a mixture of both. So the mixture हम लोगों ने जैसे बाइनरी मिक्सचर किया था, बाइनरी मिक्सचर टू कन्वर्ट टू सेपरेट द मॉलिक्यूल, we have learned how to separate the binary mixture. Now this one is a binary mixture, so we have to remove this one. To remove this one we have to give something to this. When it will get that one, it will get eliminated. So or उसको प्रोटॉन देने के लिए हमको क्या करना है, हमको प्रोटॉन को, इसके अंदर के प्रोटॉन को इसको ट्रांसफर करना है. So we need to transfer this proton already there in the benzoic acid to this. How we are going to do that one? By heating, by hydrolyzing. So दूसरा कुछ नहीं डालेंगे, उसी के अंदर से उसको ट्रांसफर कर देंगे हम लोग. So when we are transferring the proton to that, what will happen, प्रोटॉन लेके वो हट जाएगा, वो डैश वाला जो है, दिस वन इज आर डैश. तो प्रोटॉन लेगा, वो प्रोटॉन लेके निकल जाएगा बाहर. सो सो वी आर गोइंग टू ट्रांसफर द प्रोटॉन टू दिस. ठीक है, the moment when it will get proton, our molecule will become like this. So this is in a liquid form. When we are filtering, this one is a filtrate and this one is our residue. This one is R3OH is a residue. So this we doesn't require. So this one is carboxylate ion. We doesn't require this one. ROH नहीं चाहिए हमको. So this one is in residue form and this one is in liquid form. This one is carboxylate ion. That carboxylic acid, the carboxylate ion to this carboxylate ion after removing, देखो ये आया ना थर्ड स्टेप, समझ में आ रहा है ना यहाँ तक? आई थिंक इट इज क्लियर टिल नाउ. स्टेप 4 में क्या हो रहा है, इट्स क्लियर नो टू ऑल ऑफ यू? हैविंग एनी डाउट? बच्चों कुछ डाउट है? नहीं ना? ओके, प्रोटॉन ट्रांसफर होने के बाद इन द नेक्स्ट कार्बोक्सिलेट आयन जो अपने पास है, दिस कार्बोक्सिलेट आयन. So this ionic form what is there with us, this carboxylate ion, presence of sodium ion जो अपने पास ऑलरेडी था, देन सोडियम कार्बोक्सिलेट बन जाएगा. देखो हम लोगों ने इस फर्स्ट अपना था क्लियर, क्या हुआ? I'll write it. The first bond, breaking of bond between the catalyst got broken. So one is converted into sodium, another one is converted into hydroxide. So heterolytic bond fusion it is. Now we got the hydroxyl group. That hydroxyl group got attacked. Still it is remaining in the product. In the flask. Still it is remaining. ठीक है, इसको हमने प्रोटॉन दिया, हटा दिया. So that methyl group got eliminated. ऑक्सीजन इज मिथॉक्साइड गॉट एलिमिनेटेड. देन उसके बाद अपने को मिला बेंजोइक एसिड, दैट इज इन अ मिक्सचर फॉर्म. टू रिमूव दिस वन, सो इंटरनली एक्सचेंज किया हमने. इंटरनल एक्सचेंज मीन्स एलिमिनेशन फ्रॉम द प्रोडक्ट, प्रोटॉन को एलिमिनेट किया हीट करके. सो द प्रोटॉन गॉट ट्रांसफर टू दिस वन, we got the carboxylate ion. Now this one is an ionic form, negatively charged form. So when this convert in negative, the moment when it will get convert to negative, so ये जो positive अपना reaction के अंदर already है, this one got eliminated as an byproduct, residue चला गया, but इसके साथ में sodium ion है अभी, the salt is there still. So that moment this one is a pure form, the salt will get merged with this carboxylate ion. ठीक है, the salt उसके साथ में रहेगा. उसको हटाने के लिए this is our fourth step. This is our carboxylate ion already there. That positive charge which is there in the flask will get reacted with the negatively charged ion. When this positive negative will get gather up, so we are going to get our product. We are going to get our product in a salt form. The mixture of sodium the mixture of sodium and carboxylate ion. This is negative and this one is positive. ठीक है. Now down the arrow mark we have written hydrochloric acid. जब ये बन जाएगा जो ये filtrate रहेगा, to that filtrate we are going to add the hydrochloric acid. The moment when we are adding the hydrochloric acid, the sodium chloride will get eliminated, proton will get add up to this one. So यहाँ पे हमको isolated molecule of, here we are going to get our hmm, so this is the condition. Sodium add हो गया. Now we got this. ठीक है. To this we are adding, यहाँ पे हमने हाइड्रोक्लोरिक एसिड लिखा था. To this we are adding HCl, ड्रॉप ऑफ HCl. ये फिल्ट्रेट था अपने पास, ये रेसिड्यू था, इसको हमने डिस्कार्ड कर दिया. सो वी हैव टेकन दिस वन ऑलरेडी कंटेन सोडियम, दैट सोडियम गॉट एड अप with this, then we got this product, the salt containing carboxylate ion, sodium salt of carboxylate ion. That sodium salt of carboxylate ion, we need to convert this one into the pure form of acid. Now this one is in liquid form. तो जब हम हाइड्रोक्लोरिक एसिड ड्रॉप बाय ड्रॉप इसके अंदर डालेंगे, व्हेन वी आर गोइंग टू pour out the hydrochloric acid in by drop pour करेंगे, then the moment when we are adding the HCl protonating, प्रोटॉन जब हम डालेंगे इसको, प्रोटॉन एड अप करेंगे, what will happen, the sodium chloride NaCl will get eliminated. ठीक है. So this negatively charged, this negatively charged, this positively charged ion will gather up, then they will eliminate as sodium chloride, salt, and this one will get solidified होने के बाद इस, ये गया ना क्लोराइड और सोडियम निकल गया, बचा क्या, प्रोटॉन. प्रोटॉन तो इसको चाहिए ही चाहिए, इसको H चाहिए ही चाहिए. At the end it required the proton, because of that we are carrying out all these things. So H will get add up to this one. In this fashion, we are going to get the benzoic acid, the pure form of benzoic acid crystal. So this is the mechanism behind the reaction, how we are going to get our क्या भाई क्या मिला हमको, benzoic acid by methylation, sorry, hydrolysis, benzoic acid by hydrolysis of methyl benzoate in presence of sodium hydroxide and hydrochloric acid. So this is the condition of mechanism and reaction जो हो रहा है अपने फ्लास्क में. ये सारी चीजें कहाँ हो रही है, ये सारी चीजें हो रही है एक फ्लास्क के अंदर, दैट इज इन आरबी फ्लास्क. ठीक है. वो तो रिएक्शन में बना के आप लोगों को भेज दूंगी, नो डाउट. एक्चुअली आई एम नॉट गेटिंग टाइम, इतना टाइम भी नहीं मिल रहा लैब में जाने का. सो नाउ श्योर tomorrow I am having schedule. Tomorrow or day after tomorrow I am going to make the videos related to this experiment. Now the part of calculation. ठीक है. अब कैलकुलेशन का पार्ट आ गया भाई. यहाँ अपने पास है OCH3, the main part, it is main part of this medicinal chemistry or pharmaceutical chemistry, मेन पार्ट. तो इसको हम लोग भूल जाएंगे क्या किया था. NaC सोडियम हाइड्रोक्साइड हमने डाला था यहाँ पे, और यहाँ पे हमने HCl लिया था. फॉर कैलकुलेशन वी आर गोइंग टू टेक द वेट ऑफ द स्टार्टिंग मटेरियल एंड मॉलिकुलर वेट ऑफ द एंड प्रोडक्ट. ठीक है. एंड प्रोडक्ट का मॉलिकुलर वेट और स्टार्टिंग मटेरियल का वेट हम लोग लेंगे टू गेट द theoretical yield, to calculate the percentage yield. ठीक है. अब ये एक मॉलिक्यूल है, ये एक मॉलिक्यूल, इसका और इसका दोनों का, इसके अंदर से हमको कितना मिला, दैट वी आर गोइंग टू कैलकुलेट. ठीक है. अब मुझे बताओ, सो दिस इज द मिथाइल बेंजोएट. मिथाइल बेंजोएट के पास कितने कार्बन एटम है, दिस इज द 1 कार्बन. अगर मैं इसको स्ट्रक्चर फॉर्म में ड्रॉ करूंगी, ठीक है, ये कार्बन, ये ऑक्सीजन, ठीक है, और ये एक सी और ये एक स्केलेटल सिस्टम बना रही हूँ मैं स्ट्रक्चर का. ठीक है. आई एम प्रिपेयरिंग द स्केलेटल सिस्टम ऑफ द स्ट्रक्चर. ठीक है. और हियर 1 डबल बॉन्ड, 1 डबल बॉन्ड एंड 1 डबल बॉन्ड. Unsaturation. Here we are having proton, here we are having proton, here we are having proton. The H, but here we are having carbonyl group. अरे ऐसे नहीं है. So carbon atom, to this carbon atom continuation one more carbonyl group. ठीक है. So with this one O and one C, ठीक है, and H3 we are having, oh sorry, H proton, proton and proton. So अपने पास इतने सारे प्रोटॉन है. ठीक है. इसको कैलकुलेट कैसे करेंगे भाई. ठीक है. So how many H atoms are there, how many protons are there. कितने प्रोटॉन है अपने पास, चलो काउंट करते हैं हम लोग. 1 2 3 प्रोटॉन. ठीक है. 4 5 6 7. How many H are there? 7. ठीक है. How many carbon atoms are there in this molecule? ठीक है. How many carbon atoms are there? रेड से करती हूँ मैं. How many carbon atoms are there? 1. ठीक है. 2 3 4 5 6 7 8. How many carbon atom now? How many carbon atom? We are having 8 carbon atom. ठीक है. Now कार्बन
मैम हाइड्रोजन आर आल्सो 8.
बोलो कहाँ पे 8? 8. 1 2 3 4 5 6 7 8. Yes, yes, virtual chocolate for this girl. Hydrogens are also 8. Okay. Carbon also 8. ठीक है. Oxygen, how many oxygen we are having? How many? बोलो कितने हैं ऑक्सीजन? 2 ऑक्सीजन. 2 है ना. Now molecular weight of hydrogen is 1. 8 into 1. So this one is 12. ठीक है. कार्बन. Now this one is 16. हाँ अभी चलो काउंट करो, बोलो मुझे. कम ऑन फास्ट. ना मॉलिकुलर फार्मूला मैं इसका लिख देती हूँ. C8H8 and O2. ये हो गया मॉलिकुलर फार्मूला. अब मुझे बताओ, दिस वन इज 8. ठीक है. हाँ अब इसका कैलकुलेट करो. कम ऑन फास्ट.
96.
किसका? 12 into 8. हाँ 12 into
96.
12 into 16.
32.
32. ठीक है. 32. चलो अभी पूरा ऐड कर दो, सम अप कर दो, पूरा ऐड कर दो. मॉलिक्यूलर वेट पूरा ऐड कर दो, इसको ऐड कर दो.
140.
140.
140.
136.
136.
40
कैसे?
ऐड
सॉरी सॉरी मैम,
सबको ऐड कर दो बेटा, ऐड कर दो. 40 नहीं होगा, ऐड करो सबको. 130. 132. 36.
136.
136. See here, 136. Now हो गया अपना, ये खत्म हो गया. Now molecular weight of this methyl benzoate is 136. Similarly, the molecular weight of benzoic acid. Now I'm going to draw the structure for this skeletal structure for this carbon. Here one carbon, carbon and carbon. Now here one more carbon we are having, and here one carbonyl group, and here we are having one hydroxyl group. So this is a benzoic acid. Okay. Now one saturation, unsaturation, one unsaturation, carbon carbon double bond. So here we are having one H और एक H और एक H और एक H और एक H. So here one H. ठीक है, one oxygen. तो कितने H है? ये 1H, ठीक है, 2H, 3, 4, 5 and 6. So how many in benzoic acid? This is the starting material. Starting material. Starting material what we have taken. ठीक है. And now product. अब चाहिए हमको मॉलिकुलर वेट ऑफ प्रोडक्ट का. ठीक है, पूरा लिख लो. मॉलिकुलर वेट ऑफ प्रोडक्ट. फॉर दैट हाउ मेनी प्रोटॉन वी आर हैविंग? 1, 2, 3, 4, 5 and 6. 6 proton we are having. So we are having 6 hydrogen atom into 1. ठीक है. Now carbon atom, I'm going to write, figure out that one with the red. 1 carbon atom, 2, 3, 4, 5, 6 and 7 कार्बन एटम. तो हम लोगों ने इसको कर दिया. कार्बन एटम अपने पास है 7. 7 into 12. ठीक है. Now how many oxygen atom? Of course we are having only 2 oxygen atom. 2 into 16. ठीक है. Sometime 15, sometime 16. Now this one is 6. 12 into 7.
84.
हाँ, 84. 16 into 2.
32.
32 राइट. ठीक है.
Yes.
चलो अब ऐड कर दो सबको.
122 ma'am.
122. 1 exactly 122. ठीक है. 122 grams per mole. Grams per mole. 136 grams per mole. सो ये अपना मॉलिकुलर वेट हो गया. ये अपना मॉलिकुलर वेट हो गया. तो हम लोगों ने कर दिया मॉलिकुलर वेट. सो दिस इज द प्रॉपर वे ऑफ कैलकुलेशन. मॉलिकुलर वेट वी हैव डन. नाउ वी हैव टू सी हाउ वी आर गोइंग टू अप्लाई दैट मॉलिकुलर वेट टू गेट आवर थियोरेटिकल एड. थियरी ये बोल रही है अपने पास कि ये मॉलिक्यूल स्टार्टिंग मटेरियल जो है अपना, फॉर दैट. So this is the molecular weight according to the periodic table what it says. Then this is the molecular weight of benzoic acid. Then अब ये है वह ठीक है. अब थियोरी बोल रही है कि ये इतना है, ये इतना है, इतने में से अपना प्रोडक्ट कितना बना. So that is nothing but the calculation part. Calculation part. Calculation part. हमने उसको उतना बना दिया. वो molecular weight निकाल लिया हमने. We have done with the molecular weight. Now 1 mole of 1 mole of component is equal to the 1 mole of product. अब component क्या है अपने पास?
बोर्ड पे
हाँ, हेलो, कुछ प्रॉब्लम है? एनी डाउट? एनी डाउट? फरहीन? Any doubt you are having? Priyanka, Anas?
No, ma'am, no.
No ना? अरबाज? कुछ भी डाउट नहीं है? टिल नाउ इट्स क्लियर, आई थिंक सो, क्रिस्टल क्लियर. ठीक है. 1 mole ऑफ product, 1 mole of reactant, 1 mole of product, 1 mole of component, 1 mole of product. This one is nothing but the reactant, this one is a product. ठीक है. Now वन component reactant क्या है अपने पास जो react होके product बन रहा है, that is our methyl benzoate. It means 1 mole of methyl benzoate, I am going to write like this, methyl benzoate, 1 mole of methyl benzoate equal to 1 mole of बेंजोइक एसिड. 1 मोल बेंजोइक मिथाइल बेंजोएट लेंगे तो 1 मोल अपना बेंजोइक एसिड बनेगा. सो 1 मोल ऑफ रिएक्टेंट इक्वल टू 1 मोल ऑफ प्रोडक्ट मिलेगा. 1 मोल रिएक्टेंट लेंगे तो 1 मोल प्रोडक्ट मिलेगा. 1 मोल हम लोग मिथाइल बेंजोएट लिए हाइड्रोलाइसिस के लिए, देन वी गॉट 1 मोल ऑफ बेंजोइक एसिड. ठीक है. सो द मोलिकुलर वेट शॉर्ट फॉर्म में लिखती हूँ भाई. मोलिकुलर वेट ऑफ मिथाइल बेंजोएट कितना है अपना? मोलिकुलर वेट ऑफ मिथाइल बेंजोएट, मोलिकुलर वेट ऑफ मिथाइल बेंजोएट 136, 122 प्रोडक्ट का. ठीक है. मोलिकुलर वेट ऑफ मिथाइल बेंजोएट 136 ग्राम्स पर मोल. ठीक है. देन molecular weight of benzoic acid is 122 grams per mole. ठीक है. इतना है अपने पास. Now how much amount of methyl benzoate we have taken to synthesize the benzoic acid? Means we have taken mole amount of amount of amount of methyl benzoate taken. How much amount we have taken? Example, in this reaction we have taken 4 grams. ठीक है. We have taken 4 grams. So 4 grams molecular weight of taken, this one is amount taken, हमने जो लिया है, but we don't know how much amount of the how much amount of this start product we are getting. So we are going to write x gram of product or x gram of benzoic acid. Amount of methyl benzoate taken 4 gram. X, from that 4 gram we have synthesized x gram of product, that is benzoic acid. ये synthesize किया. Now we are having this molecular weight, we are having this molecular weight. Now we are going to keep the x as an constant to get our theoretical yield. Then how much we have taken? This one is 4 gram. 4 gram we have taken, 4 gram of reactant what we have taken multiplied by benzoic acid. कितना बनेगा अपना benzoic acid बनेगा 122. ठीक है. डिवाइडेड बाय अपना प्रोडक्ट कितना बनेगा भाई? अपना प्रोडक्ट है 122. ये कितना मॉलिकुलर वेट है इसका? 136. सो ये अपना थियोरेटिकल yield. You can do in this fashion also either, or one more thing, by keeping x you can calculate the theoretical yield. Amount of reactant taken, amount of reactant multiplied by molecular weight of molecular weight of the product, molecular weight of product. ठीक है. डिवाइडेड बाय मॉलिकुलर वेट ऑफ रिएक्टेंट, ठीक है, molecular weight of reactant, amount of reactant taken, molecular weight of reactant. The molecular weight of reactant क्या है अपने पास 136, अमाउंट ऑफ रिएक्टेंट क्या लिया आपने 4 ग्राम, प्रोडक्ट कितना बन रहा है 122, इसका पता नहीं हमको, मल्टीप्लाइड बाय दिस एंड डिवाइडेड बाय 136। अभी बोलो कम ऑन क्या आया, फिगर आउट करो, बताओ मुझे व्हाट यू गॉट।
3.5.
नो वी गॉट
3.5.
theory says that we are going to get 3.5 gram of compound। अब हमारी थियरी क्या बोल रही है, जब हम लोग 4 ग्राम का मिथाइल बेंजोएट हाइड्रोलाइज करेंगे तो हमको मिलेगा 3.5 ग्राम ऑफ बेंजोइक एसिड, ठीक है। सो दिस इज अवर 100% यील्ड, ये है अपनी 100% यील्ड। अब अपनी प्रैक्टिकल यील्ड जो भी रहेगी, वॉट एवर प्रैक्टिकल यील्ड वी आर गेटिंग, दैट शुड बी विद इन दिस रेंज 3.5, विद इन दिस रेंज, not it should not exceed from 3.5, it should not reduce from 3.5. If it is like that, then it means that you have followed the proper protocol of experimentation. Agar if it is coming down less than 3.5, then it is okay, less than 3 2.5 आ रहा है okay, 1.5 0.5 भी आ रहा है, then it is okay. It should not exceed from 3.5. 3.5 means 3.6, 3.7, 3.9, 3.10, 4 ऐसे नहीं आना चाहिए। अगर ये आ गया, it means that error in the measurement जो भी आपने लिया है, you whatever you have taken components, those are false, means those are not worthy, what you didn't follow the protocol. If you are following proper protocol, you are going to get your proper compound। अगर आपने प्रोटोकॉल अच्छे से फॉलो किया, अब ये ज्यादा आ गया, इफ इट गॉट एक्सीडेड, it shows that the student had not followed the protocol of the given reaction। अगर आपने प्रोटोकॉल नहीं फॉलो, वहां पे आपके मार्क्स रिड्यूस हो जाएंगे, ज्यादा दिखा दो कम दिखा दो, इट्स ओके, इट्स ओके। बट वेट एंड वेरिएशन का डिफरेंस आता ही है, इफ इट इज less then it is okay, but you have followed the protocol, it should not make sure that it should not exceed from 3.5, it's theoretically। now practically अभी हम लोग प्रैक्टिकल करें तो different student will get different weight, but it is less than 3.5. Some student will get 100% yield because they have done a proper pressure condition, environment condition, जो beaker है वो contaminated नहीं होना चाहिए। If you have followed almost all the lab protocol plus the given prescription, the given protocol of the reaction, then you will get 100% yield, ठीक है। Aseptic condition, everything you have to follow properly, cleaning, purification, everything, ठीक है। 3.5 नहीं मिला भाई, हम जैसे स्टूडेंट हैं, वी आर डूइंग इन द लैब, वी हैव फॉलोड द प्रोटोकॉल, बट समवेयर सम वेरिएशन विल कम इन द लैबोरेटरी। सो द प्रैक्टिकल यील्ड जो अपना मिला, दैट प्रैक्टिकल यील्ड वाज, मैं क्या लिखूंगी 2 ग्राम, ठीक है 2 ग्राम, मैं लिख रही हूँ 1 ग्राम ऑल्सो वी आर गोइंग टू गेट द प्रैक्टिकल यील्ड, वी गॉट 2 ग्राम। आफ्टर फॉलोइंग फुल प्रोटोकॉल वी गॉट 2 ग्राम, 2 ग्राम मिला अपने को। नाउ वी आर गोइंग टू टेक द परसेंटेज यील्ड, 2 ग्राम अपना प्रैक्टिकल यील्ड है, थियरी बोल रही है कि 3.5 ग्राम। नाउ विल सी द परसेंटेज यील्ड, प्रैक्टिकल, हाउ टू टेक द परसेंटेज यील्ड, प्रैक्टिकल यील्ड डिवाइडेड बाय थियोरेटिकल यील्ड मल्टीप्लाइड बाय 100। तो अपना प्रैक्टिकल यील्ड आया था 2 ग्राम, ठीक है। now our theory says that we are going to get 3.5 gram multiplied by 100। come on बोलो अभी मुझे कितना आया परसेंटेज, am I audible? how much you got?
55.86.
57.14.
57.86%। so we got 50, more than 50% of product, ठीक है। So like this we are going to calculate our practical yield. ये अपना रहा होल थियरी बिहाइंड द एक्सपेरिमेंटेशन. अभी समझ में आया कैलकुलेशन पार्ट? कुछ भी गड़बड़ नहीं होगी ना कैलकुलेशन में? So see what you are practicing over here in this semester, what you are practicing the calculation, it is up to completion of your final year. ये same calculation रहेगा final year खत्म होने तक. So practice it, how to calculate the, how to take the molecular weight, how to calculate everything, सब कुछ आप अच्छे से practice करो. Then at the end we are going to write uses of this benzoic acid. पता है आपको uses क्या use करते हैं? It is used an starting material for the synthesis of different kind of organic compound. Benzoic acid का use क्या है? It is used as an starting material for synthesis of different kind of organic compound. Benzoic acid से हम लोग बनाएंगे salicylic acid. Salicylic acid we are going to convert into acetyl salicylic acid. Now that one is a drug molecule. So likewise, so this benzoic acid is how, what is the use of benzoic acid? अभी वाइवा में क्वेश्चन आया आपका, क्या बोलोगे? So this is benzoic acid we are going to use to synthesize different kind of drug molecules. So this is your answer. कैलकुलेशन कैसे करना है अगर पूछेगा तो कैलकुलेशन, नो डेफिनेशन ऑफ मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, रिक्रिस्टलाइजेशन, स्टेप्स इन्वॉल्व इन द रिक्रिस्टलाइजेशन, और परसेंटेज यील्ड कैसे निकालेंगे, थियोरेटिकल यील्ड कैसे निकालेंगे, व्हाट इज द मॉलिक्यूलर फार्मूला, मॉलिक्यूलर वेट, सो व्हाट इज ग्रीन केमिस्ट्री प्रोटोकॉल, ऑल दीज आर योर वाइवा क्वेश्चंस. ठीक है, चलेगा? यू अंडरस्टूड? आई थिंक इट इज क्रिस्टल क्लियर राइट नाउ, आई थिंक सो. कुछ डाउट है? एनी डाउट बच्चों? एनी डाउट?
No, ma'am.
नो डाउट? श्योर? नो डाउट?
Yes, ma'am. No.
सागर ज्वाइन हो रहा है. अब ये सागर को ज्वाइन कराओ क्योंकि ये अटेंडेंस के लिए ज्वाइन हो रहा है. आई नो. चलो ठीक है. शैल आई एंड अप माय सेशन ओवर हियर? If you are not having any doubt means I am going to close this session. Shall I end up? I am going to forward you this recording. मैं forward कर दूंगी आप लोगों को. ठीक है? Okay, take
Okay,
care.
ma'am.
हाँ, take care. अल्लाह हाफिज.
Take care, ma'am. Allah Hafiz.
अल्लाह हाफिज. अपना ख्याल रखो, इधर उधर मत घूमो बाहर, कंडीशन ठीक नहीं है, अपना ख्याल रखो और आइसोलेट ही
हमारे
रहो
इधर
घर
कुछ
पर.
नहीं है.
नो इट्स नॉट लाइक दैट बेटा. अब हम यही बोलते कि कुछ नहीं है, बाहर थोड़ी देर जाके आओ, सर्दी, you will get attracted with the flu virus. Flu तो है ही है बाहर.
Yes, ma'am.
We don't know when that flu will going to be convert into the symptom of corona. So इसीलिए ना बाहर जाओ ही मत. कितना जितना हो सके अपने घर वालों का भी ख्याल रखो, अपना भी ख्याल रखो, सब